So we are reviewing for our test on chapter 3 tomorrow. And so there's the angle relationships that we learned about. We learned about adjacent. That was the first one. Then we had linear pairs. I'm going to make sort of some quadrants here. We had adjacent, linear pair, and then we had complementary. And vertical. Where am I going to stick vertical? All right, so please, everybody, pay attention to me so I can sort of recap what each of these things is supposed to be and what they look like. All right, adjacent literally means next door neighbors. Well, okay, it doesn't literally mean next door neighbors, but that's our easiest way to remember it. Okay, next door neighbors. So they can look lots of different ways. It could look like this. Angles 1 and 2 right there are adjacent. They are right next to each other. It could look like this. Angles 3 and 4 are right next to each other. Those count as adjacent. Okay, so there's lots of different ways that it could appear, but as long as the two angles that you're talking about are right next to each other, so I don't know, I'm trying to think of how else I could, maybe you had two like this, right? And you were talking about angles, what am I up to, 5 and 6. All of those angles that I've highlighted there, they would all count as adjacent because they're all next door neighbors, okay? That's what adjacent means. That's it. That's the only requirement, is that they are next door neighbors. Linear pairs. This is the rainbow that I keep mentioning. They have to make that full rainbow together. Have to. So what you need is a straight line and then some angles coming off of it. So like that. See how they make the full rainbow together? That's what I have to have for a linear pair. So other ways it could look, maybe the lines are a little bit longer. And I'm talking about angles 3 and 4, let's say. I still have the full rainbow when I fan over those angles. That is exactly what linear pairs look like. So they have to be adjacent and make a straight line together. The full rainbow, have to have it. Just trying to think one other way that I could look like this, maybe. I still have that full rainbow. That's what a linear pair is, okay? Complementary, these are the ones that have to add to be 90. So you have to start with a 90-degree angle, okay? Have to have a 90-degree angle. Or they have to have a sum of 90 degrees. So they could actually be separate. So you could have an angle here and an angle here, as long as I knew that this was, I don't know, let's say that this was 50 degrees and this was 40 degrees. That counts because they add to be 90. That counts. Okay? Supplementary, same thing, but now I have to add to be 180. So yes, they could look like this. Those add to be 180, right? They make that full line together. So they could look like that, but they don't have to touch though. They could be separate. So you could have an angle here and another angle over here. And as long as you knew, let's say this one's 100 and this one's 80, together they still add up to be 180. So that still counts. Okay, and then vertical, this is when you have to have an X. And then it's the ones that are across the way. That's a vertical angle pair. That's a vertical angle pair. You have to have an X though. That's a vertical angle pair. Okay, and the big deal about vertical angles is that they're always equal. So if I were you, I might take a little screenshot of this. How do I do it on the iPad again? Do you guys remember? Is it like and I have a home button. Is it home button and down? Nope. That didn't work. Let's try home button and up. Nope. Home, is there a power button? Yeah.
Do the power button and like the home button.
What? Say it again. I'm sorry.
Do the power button and the home button.
Power and home?
Yeah.
Yay, you did it. Thank you. Okay. All right. So everybody has this? This is a great reference, and you can use this tomorrow, right? You guys, you can use, don't forget that there's a whole folder full of reference sheets that Mrs. Muska has created. So, and it has all of this information in there. You are welcome to use this. Everything is open notes and open, it's not open internet. I mean, can I stop you from Googling something? I guess not, but I would prefer that you don't. Okay? Notes? Yeah, go for it. My notes are posted. I'm sure you have a lovely notebook. Okay, so let's get back to the, let's stop this share and let me go back to this. So now that we have sort of recapped what those angle relationships are, these two, they're next door neighbors, aren't they? So I'm absolutely going to click off adjacent. Oh, I don't know if I can actually do it. Yeah, I don't think I can actually click it on my end because I'm not actually taking it. It would be like editing this. Anyway, so these should be adjacent. Those aren't vertical. That didn't look right. If we look back at our picture, that's not what that looked like. Linear pair? No, that has to make a whole rainbow. So that's not that. Complementary, they have to add to be 90. I don't know that these two add to be 90, so I can't make that. Supplementary has to be add to be 180. It's definitely not that. And that was it. So the only thing that works for this one is adjacent. That's it. Let's look at the next one. So these two, angles 1 and 2. Notice, check this out. Look, don't they make the full rainbow? Yeah, they do. So they are adjacent. They're next door neighbors. So I would pick that. Not vertical. Not that. Linear pair, you bet they are, because they make that full rainbow. Complementary means that they add to 90. That's not this. It's supplementary. So I would pick supplementary because they do add to be 180. And that's it. Okay, so this one should have been adjacent, linear pair, and supplementary. Those are the three that work for this one. This one, ooh, right away I'm saying, ooh, those are vertical. I know it. And guess what? I don't know if you remember this from when we learned about vertical angles, but I had told you there was a star in our notes. Vertical angles can never be adjacent. You will never have a time when you check off adjacent and vertical in the same question. It's impossible. So these are vertical. Are they a linear pair? Heck no. Are they complementary? Let's see. 35 plus 35. Is that 90? No. So nope, they're not complementary. So they're also not supplementary either, right? Because 35 and 35 is not 180. So the only one for this is vertical. These two. All right. They are not adjacent. They're not next door neighbors. So I'm not going to pick that. They're not vertical because I need that X. They got to be right across from each other. So no. Linear pair. Nope. They don't make that full rainbow. Complementary means that they add to be 90. Well, 30 plus 60 is 90. So yeah, I would have to pick complementary. Supplementary, no, because they add to 90, not 180. Okay, let's try this one. Are they next door neighbors? Yes. Are they vertical? No. Those are not vertical angles. Linear pair? You bet. Look at that full rainbow. Oh, we got a double rainbow because they already had one there. Linear pair? Yes. Complementary? Do they add to 90? No, but they add to 180, so I'm going to check off supplementary. Those are my answers for that one. Okay. All right. This one, oh, I tell you that this is a trick question. And the reason why this is a trick question was because I thought that some of you were going to make an assumption about this diagram, which you can't do. All right, so let's sort of go through this one by one. Are they next door neighbors? Yes, they are. They are that. They're not vertical. No. Linear pair? I don't get a full rainbow here, do I? That's not a full rainbow, so no, I don't get that. So I'm not picking linear pair. And here's where I think I might have tricked some of you. Are they complementary? Do they add together to be 90? You have no idea. Maybe, right? I don't know. My point is, I don't know that this is a right angle here. Nothing said that angle CBA was a right angle. So you can't assume that it is. Just because it looks like it might be, you can't go around assuming that. That's a big no-no. So all I can say about these two is that they're adjacent. That's the only thing that I know for sure. Oh. All right, now we're moving on. Here you just had to give me equations, and then I asked you to solve the equation. So hopefully you realized, oh, look, those two together make a full 180 degrees. So the equation this time would be the sum of these two equals 180. Okay, so there's only one choice that had the sum equaling 180, so you should have picked that one. If you picked the right equation, then the next question just asks you to solve that equation. And I think, I don't remember what it comes out to be, so let's do it real quick. Let me change the line width here. Okay, so our equation was 2x plus, oh, whoa, what's happening? Why did I just zoom like that weird? I don't know. 2x plus 3 plus x minus 6 should equal 180 altogether. So there was my equation from the last question, and now I just have to solve it. So 2x and x is 3x. A positive 3 and a negative 6 is a negative 3. And then just add that 3, and now you guys are just solving like you always do. So whatever 183 divided by 3 is, was that 61? Yeah. 61, there it is. Right, sorry, divide by 3, divide by 3. Okay, so in my quick scanning, it seemed like most of you guys were okay-ish with the equations and solving it. All right, so do just let me know if you are still struggling there. Let's see if we can figure out this next one. All right, this next one, what's going on here? Well, I do know that this angle is 90 because it has that little box there. So I can confidently write the equation that says, all right, these two angles have a sum of 90. So what am I going to say? I'm going to say 7x minus 9 plus 4x equals 90. By the way, if you had written your equation like this, 4x plus 7x minus 9 equals 90, it doesn't matter. Aren't those two equations exactly the same? It doesn't matter if you say this angle plus this angle or the other way around. If you're adding, who cares? So there is only one choice that has the same, you know, if you wrote this down on your paper, but you don't see that as a choice, I'm hoping that you can realize, oh, well, this is just the same thing. Right? Those are the same. Doesn't matter which angle we add first. Okay, so there's our answer for that. Now in the next one, I just have to solve it. So let's go ahead and do that. Just erase some of these pieces that I don't need now. Okay, so solving this equation, let's see. 4x and 7x is 11x. Minus 9 equals 90. Add that 9. 11x equals 99. So I'm getting the x is just 9, which is a choice. Yes. I love that. Any questions so far, guys? You're very quiet over there. Okay, let's try the next one. All right, this one's actually pretty much the same idea, right? I have two angles together, and it looks like their sum is going to be 90. So I should get 8x plus 5 plus 3x plus 8 together is 90. So let's see, is that a choice here? Oh yeah, the middle one. So I feel good about that. So now let's just scroll on down and solve it. Okay, 8x and 3x is 11x. 5 and 8 is 13. Oh, what am I doing? Writing the wrong thing. 90, silly goose. And then I'm just going to minus that 13. So I get 11x equals 77 in this case. Divide by 11, divide by 11. And I get 7, which is a choice. So I'm feeling good. Okay. All right. Ooh, vertical angles. So hopefully when you get to this question, you're like, oh yeah, those are vertical and I know exactly what to do. Vertical angles are always equal to each other. So I'm literally just writing 11y minus 36 equals 63. Okay, let's see. Is that an option? Yep, it's that first one right there. So I'm confident in that. So let's go ahead and solve it in the next frame. So I'm just going to add 36. So what's that, 99? Divide by 11, divide by, a lot of 11s popping up in this. 9 is my answer. And it's a choice, so we're feeling good. Okay, let's keep it going. Ooh, all right. So I highly recommend, especially for ones like this, please just copy this down on your paper. It is too hard to write the equation without like literally drawing on this. So just write it on your paper and then fill in what they tell you. So let's see, NMG, that's this angle right here. They're telling me that that's 46. Okay, 46, got it. NML, that's the whole angle. That's 11x plus 11. And then they tell me GML is 8x minus 5. So if you remember, we had talked about setting up these model equations where the two smaller angles just add together to be the bigger angle. That's all I'm doing here. I'm going to add the two smaller ones together and set it equal to the whole thing. That's it. So my equation would look something like 46 plus 8x minus 5 equals 11x plus 11. That's my equation. Add the two smaller together, set it equal to the whole. Is that a choice? Yeah, it looks like it's the second one down. Okay. I hope that one wasn't too bad. So now I'm going to just scroll down to the next one and solve it. Oh, there we go. I'm like, did I not ask you to solve this one? I did. Here we go. All right, 46 and a negative 5, that's 41. Now, I also notice that I have x's on both sides. I'm going to get them together. So I'll minus 8x minus 8x. So that's 3x plus 11. And now it's a much simpler equation. We'll just minus the 11. So I get 30 equals 3x, divide by 3. Hey, this ain't so bad. Look at that. I got 10. By the way, I know I'm going quickly through this, but on your test tomorrow, I would highly recommend that you take the time to check your answers, right? Plug them in and make sure that they actually work. But I'm kind of short on time here. And then for whatever reason, I thought that these triangle questions were going to be easy, but a whole bunch of you got it wrong. I don't know if I didn't word it great. There's no questions quite like this tomorrow. I was just trying to give you a quick way to, instead of me asking you 10 times, is that an obtuse angle or an acute angle? I just thought this would be faster, but sorry if it was confusing. So what I wanted you to do, every triangle has 3 angles, right? 1, 2, 3. I just wanted you to count up how many of those angles appear to be obtuse. Obtuse are bigger than 90, right? Angle 1 is definitely not bigger than 90. Angle 2, yeah, that one is. That's a big old angle. Angle 3, nope, you're smaller than 90. So out of those 3, only one of them appears to be obtuse. So my whole thought process was that you would just type in the number 1 there. And then when I ask you on the next one, how many of them are acute? Well, wouldn't that one and that one be acute? So this one should have been 2. And then for how many right angles? None of them appeared to be a right angle. So you should have just entered a 0 on that one. Okay, and then I finished it up with some true false, I believe. 2 lines are perpendicular and form 4 angles. If I use that word perpendicular, that has meaning. That means if 2 lines are going to be perpendicular, they have to intersect at 90-degree angles. So I'm asking you, are all 4 of those angles going to be right angles? Yes, they have to be. Otherwise, your lines aren't perpendicular. So if I know I have perpendicular lines, they're all right angles. They have to be. So on that same thought, let's read the second one. 2 lines are perpendicular and form 4 angles. True or false? Those 4 angles will all be congruent to each other. Are all 4 of these angles equal in measure? You bet they are, because they're all 90. They're all 90. So yeah, they're all congruent. True. Let's try this next one. If you bisect a right angle, so let's talk about that. You have a right angle. Remember what bisect means. It means to cut it equally in half. So wouldn't you get 2 little 45s? Is that 2 acute angles? Yeah, it is. So that's true. The next one down, if you bisect a straight angle. So remember, a straight angle looks literally just like that. Looks like a straight line. It's a full 180 degrees. So if I bisect it, that means I'm cutting it exactly in half. If it was 180 and I cut it in half, aren't these now both 90s? So did I create 2 acute angles? No, I didn't. That's false. I created 2 right angles. Okay, and then, is this the last one? It is. Check all the ways that you could name this angle. So remember, the vertex has to be in the middle. Has to be. So as I'm looking through this, HGF, yep, that's good. But the next one down, GHF, you can't have that because G is the vertex, so G has to be the middle letter. So I can't choose that one. So you're wrong. FGH, yeah, that one's good. That's got G in the middle, exactly what I wanted. Can I call it just angle G? In this diagram, you can. Remember the rule. If there's only one angle that has that vertex, you can get away with calling it just angle G. So that does work. Oops. But I can't call it angle H. I can't call it angle F. I could call it angle 4, though, right? It's got the number in there. You can call it angle 4. And then I threw in GFH. Yeah, I can't do that because I don't have G in the middle. So that last one is out. But I don't know if I can cross it out. I got stuff in the way. There we go. And that's it. Does anybody have any questions about this? Any of the problems that were on here? Are you sure?